Good morning, everybody. Today we have the last lecture of fluidistat. Okay. Today we have to discuss rigid body motion. I think there may be some difficult questions with homework number 4. So I will try to give a solution manual for that homework, right? I think the number of submissions was less. Still, I think you are still doing the previous set of homework. The most of the questions that some students asked were related to homework number 3, right? The less number of inquiries for homework number 4. Therefore, I think you are still try to do them. Therefore, I wish to directly move into the today's topic, which is the rigid body motion. Okay. All of you, shall we write down the topic? Rigid body motion. Rigid body motion. We are discussing fluid statics here. So after completing fluid statics, we have to discuss fluid dynamics. Okay, we are going to discuss fluid dynamics. So before discussing fluid dynamics, we have to discuss dynamics. Once we complete dynamics, we can discuss fluid dynamics. Therefore, the dynamic will be covered later. Okay, the rigid body motion, all of you, the rigid body motion is also type of motion, but it's a specific type of motion, right? Therefore, we can discuss it under the fluid stat. In other words, this is a it's a relatively stable or relatively rest situation, the rigid body motion, right? So this is the definition of rigid body motion. Look at when a fluid in a container, there's a fluid in a container, right, is subjected to a motion. There's a container, fluid container, then container is moving, right, such that there is no relative motion between fluid particles, right? The relatively rest, all the fluid particles are relatively rest. Such motion is known as a rigid body motion. We will write down the definition of rigid body motion. When a fluid mass in a container is subjected to a motion. Shall we write down the definition? When a fluid mass is in a container, is subjected to a motion such that there is no relative motion. There is no relative motion between fluid particles. Such motion is known as rigid body motion. Okay, Normally, when we study motion in dynamics, we consider two types of motions, the translational motion and rotational motion. අපි සිංහලෙන් කියන උත්තරණ චලිත, moving in a straight line or a rectilinear motion, it's a translational motion. And the rotational motion, right? Therefore, when it is the motion can be either translational motion or rotational or combination of both. In this discussion, we only focus in the translational motion and rotational motion only. Okay, no need to write it down. Normally, when it is motion, it is either translational or rotational, right? Or can be a combination of both. So in this course, so under the fluid mechanics, we only discuss the effect of translational motion and the effect of rotational motion of a fluid. Because when we have the combination of both, we have to use some advanced mathematics, in other words, the polar coordinates and all, cylindrical polar coordinates, in order to handle it. Therefore, you have to only focus on the translational and rotational motion. So we will start with the first one, translational motion. Okay, the translational motion. We are going to focus on translational motion, and it is the okay, translational motion. All of you think that there's a fluid, there's a fluid container. Okay, now it is at rest. The container is at rest. Let's say we will keep it in on a trolley or somewhere. Right now, it is at rest. Velocity is 0. Acceleration is 0. Normally, we know that when the fluid is at rest, the free surface is horizontal. When we go down, the pressure increases. When we go down, pressure increases. So these are the constant pressure lines. Constant pressure lines are parallel to the free surface. Now, think a situation that this body is subjected to an acceleration. This is x direction, acceleration of ax. Then it can be analyzed and show that what happened to the free surface by practical experience, or by what happened to the free surface now when it is subjected to horizontal acceleration. I think you have some idea. Here we are not going to prove these concepts mathematically, because we have to use advanced mathematics, especially multivariable calculus. When it is subjected to horizontal acceleration, what happened to the free surface? Right? The free surface will be inclined now, right? Actually, the backward height will be high and the front height will be low. There will be inclination. When we inclination, so this is the free surface now, right? This angle of inclination, let's say theta, it can be shown that the tan theta is equal to ax over g. We are not going to prove this in the university also. You don't have to prove this, you have to directly use this. right? And if you look at the pressure lines, so this will be the pressure lines. So these are called constant pressure lines. Constant pressure lines or isobars or constant pressure lines. Okay. So we have to use this equation and do certain analysis. Okay. So first case is the translational motion. We have considered horizontal acceleration. Then we are going to look at the vertical acceleration. Then we are going to look at combination of both horizontal and vertical acceleration. Shall we draw this diagram and copy this down? Actual analysis is based on calculus. It is based on multivariable calculations, total differentiation, gradient and all. Case B. Vertical acceleration. Vertical acceleration. If the acceleration is in vertical direction, let's say vertically upward. If it is vertically upward, acceleration of vertically upward, the free surface is now inclined free surface. Now the horizontal free surface. This will be the pressure distribution of the wall. Now this is the new pressure distribution of this side, the back side, and this is the pressure distribution of the front side. So in this case, what happened is the free surface is horizontal, but the pressure, let's say this height is h, then this pressure is given by, pressure at this point is given by rho g plus a z h, right? The vertical acceleration component a z also added. Therefore, these are the constant pressure lines. But the thing is that compared to the previous distribution, compared to the normal distribution, the new distribution will be little bit wider. Okay, so this is the rho g h part, and the whole thing is the rho g plus a z h part. Now the pressure will increase when it is moving upward. If it is moving downward, G minus AZ is the effective pressure, effective acceleration to calculate the pressure. These are called isobars. Okay, isobars. මේ අපි ඇඳලා තියෙනවට කියන්නේ isobars කියලා. මේවා this line having the constant pressure. This parallel to the free surface. If you draw a line parallel to free surface, if you draw a line, that line having a constant pressure. So these are constant pressure lines, so isobars. Isothermal, isobaric, you can remember that term. Isobars. Isobars means constant pressure lines. So this is the new, this whole thing, and when make the mind, the red one is the new pressure distribution due to upward vertical acceleration. If it is downward acceleration, then this is G minus, the effective acceleration is G minus AZ. You can see that if the downward acceleration is G, then the pressure will be 0. Pressure will be 0 at anywhere, at everywhere of the fluid. It will be the atmospheric pressure. Horizontal, vertical, C is incline acceleration. Incline acceleration. Let's say that horizontal acceleration is AX and there's a vertical acceleration of AZ. Right? Normally in most of the books, this direction is considered as X, right? Into the board is considered as Y, and top of the board is considered as Z, right? There can be the horizontal acceleration can be two ways, right? But always when there's a horizontal acceleration, you can find the resultant horizontal acceleration. The direction of the resultant horizontal acceleration is X now, right? When we have both X and Y, the tan theta is given by AX over G plus AZ, right? This is the equation that you have to memorize. If it is upward, positive. If it is downward, you have to put the negative value. So equation wise or theoretical wise, these are the things that you should know. But when it is a practical problem, you have to use certain strategies in order to solve the problem. Okay, we will look at the first example available in the tute. If you turn to page number 57, you can find the first problem. Example 7 කියලා තමයි number එක දාලා තියෙන්නේ. Try this example, all of you. Tute එකේ 7 කියලා එක නම්බරින් වල පොඩි ප්‍රශ්නයක් වෙලා තියෙනවා. You can try this. Open tank 5 meter long, 2 meter deep and 3 meter wide, contains oil of relative density 0.9 to depth of 0.9 meter. If the tank is accelerated along its length on a horizontal track at a constant, think about a Bowser or a petrol tank of a vehicle, right? So if the vehicle or Bowser is or aeroplane is in acceleration, then the fuel in the tank is subjected to motion that you are talking here. This is an open tank. The new position of the oil surface and the pressure at the bottom of the tank and the bottom of the tank at the front and rear edge. Okay, front and rear edge. So we will draw the original tank and the tank subjected to acceleration. Acceleration is given along the length. So this is the tank, right? And it's 5 meter long, 2 meter deep, three meter wide. It's a free surface. Relative density is 0.9. And the initial water level is also 0.9. Okay, the density is also done. A relative density scale is 0.9. So okay. Okay, so first thing is that now the thing is that it is subjected to acceleration along the length. Let's say AX, the acceleration is 3 0.0 meters per square centimeter square second. Okay, so initially we can calculate the required inclination tan theta. Right, normally think that actually there are some basic facts that we have to consider. I will explain all these things along this example. So tan theta is given by Ax over G, X over G 3.0 over 9.81. You have to put 9.81, right? Then you can calculate theta. Theta, expected inclination. Calculate theta. Tan inverse 3 divided by 9.81. So it is 17.0 degrees. Okay, 17.0 degrees. Okay, normally when this is going to incline, all of you, when this is going to incline, right? Initially horizontal. So this surface from the front end, this will go downward direction, right? And from the front end, it will go upward direction. That is what is happening. All of you look at. Let's say the container is filled very close to the top, right? Then what happens is when it is when this part moving downward, this part moving upward, right? There's an instant where so initially you can see the amount going down is equal to amount going up. No, therefore initially the free surface hit the top of the tank, and if it is open tank, they're going to spill. If it is further, there will be some water or liquid going out from the container, right? Now in this situation, this is a 2-meter height tank. No, the water level is 0.9. Therefore initially when the water level at the front is at the bottom, from the other side it will not go to the top, right? So depending, if it is filled more than half, first it will reach the top end. If it is filled less than half of the volume, half of the height, first reach to the front end. Okay, so normally what happens is, if it is situation like this, first it will be something like this, then gradually increase, and then come to here likewise. So this kind of situation is expected, right? So if you calculate this angle, this is a midpoint. When the free surface is at the bottom of the front end, right? This is 0.9. From here it is also 0.9. Then you can calculate this limiting angle alpha. So tan alpha is this height 0.9 into 2 divided by this base 5. Then you can calculate value of alpha. All of you, tan inverse 0.9 into 2 divided by 5. So alpha is 19.7, 19.8 degrees. But this theta is 17. No? This theta, according to the acceleration expected inclination, is 17 degrees. Therefore, in our situation, it is not like this. But there's another critical point, right? If we further accelerate, right? If we further accelerate beyond this, then this point will come somewhere here. And this point will go up. From that point, it is going to spill out, right? So initially, we have to check whether free surface will hit the bottom of the tank or top of the tank. So in this case, the amount of initial water level is less than half, no? Less than half, no? Therefore, we have to check whether it is hitting the bottom of the tank. So this theta is less than alpha. Therefore, the expected situation is something like this. When we want situation, so this is the new free surface, and this angle is theta. This angle is theta. Okay, you can start the calculation. Where the question is the new position of the oil surface. New position of the oil surface. මේ පල්ලෙහාට යන ටික අපි දැම්මොත් A කියලා. ඒක equal වෙනවා මෙතනින් උඩට යන ටිකට. Draw a dotted line here. This dotted line is the original level. The black color one is the new level. And tan theta, you can write down tan theta again, 2a divided by 5. In that way, we can find the new position of the water surface. Tan 17 into 5 divided by 2. The value of A is 0.764 meter. 0.7. Should be less than 0.9. Initial level is 0.9. This A is, it must be less than 0.7. You have to, based on the boundary conditions, you have to always logically There's another part of this question. In that question, it's we have to calculate for another acceleration. That acceleration is greater than 3. Okay. So here the question is the new position. Now we have found the new position, and also we have to find the pressure at the bottom of the tank and the at the front and rear edge. You say this is A and this is B. So what we have to do is we have to calculate PA and PB. So PA is given by rho G H, no? So rho G H, in this case H is 0.9 minus A. 0.9 minus A. So rho is also 0.9, 9790 into 0.9 minus A. Okay, this is value of PA. Then it is PB 0.9 into 9790 into 0.9 plus A. 0.9 plus A. Okay, in that way we can calculate the pressure. If you look at the this is a symmetrical situation. Okay, when this is a symmetrical situation, when we the amount going down is equal to amount going up. Therefore, always this inclined surface passing through the midpoint of the original free surface is a uniform one. If you want, you can complete a triangle here. It's 2A over 5. If you look at the pressure distribution at the bottom, here this is the height, right? This actually the pressure distribution is of the bottom. Pressure distribution of the bottom of the tank is simply you can draw the new water line. Okay, originally bottom of the tank having constant pressure. Now the bottom of the tank having a pressure distribution which is rho gh likewise, and may wage එකක් තමයි right. Yeah, the next part is you have to new position of the oil surface and the pressure at the bottom of the tank at the front end edge. Okay, we'll go to the next example. The tank in example 1 is given a horizontal acceleration of 0.5 meters per square second. Calculate the amount of spill. Okay, now the thing is that now the acceleration is further increased. Now the acceleration is 4.5 meters per square second. So it says that the question is calculate the amount of spill. Amount of spill වෙනවා කියන්නේ එළියට යනවා කියන එකනේ. මේ වතුර මේකෙන් ඉවත් වෙච්ච ප්‍රමාණය තමයි calculate කරන්න තියෙන spill. Amount of spill. So definitely in this point, at this point, right? So if you further accelerate, what happens? This point will go down and hit A. At that time, this point is not at the top, but somewhere you can find a situation like this. Look at, let's say this angle is beta. Okay, this angle is beta. Because at this instant, this is the limiting instant. This is the place where start to spill out water. We can calculate this length B. How can we calculate this length B? Hmm? All of you? Uh, so this B is the place where the limiting point or critical point, the place where start to spill. What we can do? We have to equate what? Equate the original volume and the new volume. Okay, we can equate volumes now. So initial liquid volume is 0.9. Initial volume that actually we can equate cross sections. Initial volume is 0.9. 0.9 into 5, that should be equal to half into base into height, 2 meter. Then you can calculate value of B. B is 4.5 meter. Is it possible? Yes. It's less than 5. Then we can calculate tan beta. Tan beta. Tan beta is 2 over B. 2 over B. Therefore, we can find the value of beta. We'll see what is beta. Actually, the question to question analysis is different. With this example, you can understand a lot of analyzing techniques. Okay, 2 over B, 2 over B, tan inverse 2 over B, B is 4.5. Then the angle is 23.996. Okay, here we can calculate the new angle. We can put 4.5 new theta, let's say theta dash or theta 1, theta dash, tan inverse 4.5 over 9.81. It's the new theta is 24.6 degrees. I can see that this theta dash, the theta dash is greater than alpha. It is even greater than beta. Therefore, this will be the new situation. Something like this. Theta dash again. Is it clear? This theta dash is it is greater than beta. Alpha value කොහොමද? Therefore, this will be the new position. Like us, the question to question, the way that analyzing is different. Any problems? So beta alpha is the limiting point to touch the bottom of the tank. So beta is the limiting point to touch the top of the tank. Okay. So in this case, you have to actually, the question is given, you have to calculate the amount of spill. That means we know definitely it is spilling, but you have to uh, judge based on beta. The inclination is now greater than beta, no, that's why the water is going out. Can our original volume එක මේ volume එකට equal වෙන තැන තමයි beta වෙන්නේ. Volume එක වතුර ඊට පස්සේ තමයි එළියට යන්නේ. theta dash. Now we have to calculate the difference. Amount of spill, let's say delta V. The delta V is V1 minus V2, V1 minus volume 2. So to calculate volume 2, we should know this base method. C කියලා. Okay. කට්ටිය අහන alpha හෙව්වේයි beta හෙව්වේයි කියලා. අපි දැන් theta alpha ට වැඩි අඩුයිනේ, ඒකින් හින්දා තමයි කලින් අවස්ථාවේ මෙහෙම තියෙනවා. මේක මේ පැත්තෙන් ටිකක් පහළට ගිහින් මෙහෙන් උඩට පහළට ගිහින් එන්න පුළුවන්. ඊට ටිකක් වෙලා යද්දී theta ගියාගේ alpha වුණාට පස්සේ තමයි මේ අඩියට වදින්න ගන්න. ඊට පස්සේ අඩිය මතුවෙනවා. ඊට පස්සේ theta ගාගේ beta වුණාන් පස්සේ තමයි හරියටම මේ මෙතෙන්ට වතුර මට්ටම එන්නේ. beta ට වඩා වැඩි වුණාන් පස්සේ තමයි වතුර එළියට යන්නේ. ඒකයි. මේකේ වතුර එළියට යන්න ඕනේ. දැන් අලුතෙන් අපිට තියෙන්නේ initial volume එක වෙන්නේ 0.9 into 5. Now half into base into height, no? Half into C into 2. These are cross sections. So multiplied by 3. Then we can find the amount of spill. C එක හොයාගන්න පුළුවන්. C කියන්නේ C is 2 cot theta dash, no? Cancel. C is 2 cot theta dash into 3. That we can calculate the amount of spill. Theta is 24 now. 20.46 into 3. Therefore 0.394395 cubic meters. ප්‍රශ්න මොනවා හරි තියෙනවා අහන්න. Always we have to use the tan theta is equal to ax over g. right? So this is a closed tank, right? Then there's another question with an open tank. This is an open tank, so there's another question. Next question is based on a closed tank. Shall we go to next example? දශම 4.2 කියලා තියෙන්නේ. Why is that? Is this a correct 0.95? Okay, all of you try example number 3. It's a closed tank. Open tank, closed tank. Closed tank. Top has an opening in the front part. That means same pressure, atmospheric pressure inside, right? 6 meter long. 1.8. The initial water level is 1.2. So 1.2 is more than half. 2 meter wide. සිදුරකුත් තියෙනවා කියලා කියන්නේ. The acceleration is given. Acceleration is given as 2.4 meters per square second. First thing, we can calculate theta. So tan theta is ax over g, 2.4 over g, 9.81. Then we can calculate theta. Tan inverse 2.4 over 9.8. එකයි දශම 4යි නේ හරිනේ 9.8යි it's 13. So theta is 13.75. theta is 13.75. We don't know whether this with this angle it will hit the free surface, it will hit the uh, top surface of the tank. Now the tank is filled more than half, no? All of you. So tank is filled more than half. This is 0.6. This is also 0.6. No? So you can calculate this alpha. Alpha. Alpha is another point that you have to consider. Then you have beta. Beta. Okay, what really done it? So anyway, you can calculate alpha. Let's see, tan alpha is equal to 0.6 into 2 divided by 6. We can calculate alpha. Tan inverse. This is 11.31. Now this theta is greater than alpha. Therefore, definitely a part of the liquid will touch the top of the tank, but other surface we are not sure whether this part is hit the bottom of the tank or not. Actually, we can find it. We can find that beta value and we can compare, but with an assumption we can go ahead. With an assumption we can go ahead. We will assume that situation is something like this. We will assume that the situation is, I will draw it in another color. We will assume that I will draw it in black color. Let's say this is the situation, but we don't know whether it is. I'm going to assume that this end is still available. This height is still available. It will not reach to the bottom. Therefore, this angle is the theta, right? So to find the new positions, actually our question is calculate the total pressure force on the top of the tank. Calculate the total pressure force on the top of the tank. No? That is a question. Contact so we have to find, all of you, let's say this is also theta, all of you. Let's say this is let's say this is A. If this is A, this is A tan theta. So a tan theta must be a tan theta must be less than the total height 1.8, right? This a must be less than 6 meters. If this is possible, all of you, we have to assume this, right? Because there can be another case. If this is acceptable, the a tan theta must be a value less than 1.8. මේක අපි ඕන b කියලා දැම්මොත් මේක b කියලා දාන්නකො. So this is b. So b must be, it must be less than b. කියන්නේ මෙතන ඉඳලා pre-surface එකට තියෙන. So b is in between 0.6 and 1.8, right? Otherwise this is not practical. There can be another case. So the thing is that how the volume is concerned, so we can equate volumes. Actually, in this case, not only in this case, most of the cases, it is easy to equate the free spaces. The original free space is equal to the new free space. Space within the volume, the space within the container. Therefore, you can equate the volumes, free spaces. So initial free space is 0.6 into 6 now. With this not, you can use a1 equals a2. Now it is half into a into b. This b is equal to a tan theta and b divided by a wala 10. B divided by a is tan theta. Therefore b is a tan theta. A squared tan theta. So we can find the value of a. Well, value we go in available. The AB දාගත්තේ ලේසි එහෙම දාගත්තා නැත්නම් මේවා දාගත්තම පොඩක් කරදරයි. හරි. 0.6 into 6. 0.6 into 6 years. 0.6 into 6. That is the 0.6 into 6 is the original free space. Into 2. 0.6 into 6 into 2 divided by tan theta. මෙම මේ theta කියන එක ගාව ගන්න නැතුවම මේ දෙක දාලා එහෙම ගාලා හදන් ගියත් හරි. Theta compare කරන වෙනකොට tan theta compare කරන්න පුළුවන්. Instead of comparing theta, you can compare tan thetas. Practically එහෙම කරන්න පුළුවන්. Divided by tan theta. Tan theta කියන්නේ 1.4 බෙදි 9.8. 29ක් එන්නේ. a squared එකට එන්නේ 29ක්. ඒකේ වර්ගමූල ගන්න. 5.425. a 5 point ගානක් එන්නේ. a 5 point ගානක්. It should be less than 6, no? Okay. What about b? b වලට එන්නේ ඒකම tan value එකනේ. Answer tan 13.75. Try the Shimura. 1.33. So this is 1.33. 1.33 Ganakin. 1.3. That is correct. Therefore, the situation is acceptable. පාරගන්න පුළුවන් නේ තත්ත්වය. මේක 1.8ට වැඩි අඩුයි. 0.6ට වඩා වැඩි. 0.6ට වැඩි වෙන්නත් ඕනේ. Okay, now we have to calculate, but we have to calculate this the force exerted on the top of the tank. Force exerted on the top of the tank. බලමු කොහොමද කරන්නේ කියලා. ප්‍රශ්න තියෙනවා නම් දාන්න. B is the height to the free surface. Right? Initially it is point. Initial B means here to here, right? Initially 0.6. So it should be greater than 0.6, but the whole length must be less than 1.8. Now tell me, how do we calculate this force? The force, the pressure at this point, let's say this point is A. So this point having atmospheric pressure 0. If you can calculate the pressure at B, if you can calculate pressure at B, you can calculate force on the surface. 2 meter ni y දෙක 2 meter meter 2යි මේක A 6 minus A මේක 6 minus A. This is a hydrostatic, this is something like hydrostatic force calculation. So if we use the force is equal to simply the force is equal to pressure into area, we can calculate the pressure here PA near PB. So we divide by 2 average into the area. Area is 6.6 minus A into 2. We know that actually there are a lot of ways to calculate this force, right? So this is the simplest method. So we can find the average pressure into area, or we can use any other method that we have learned so far. Now tell me, PA is 0. PA is 0. How do we calculate PB? කොහොමද අපි PB calculate කරන්නේ? All of you, tell me, how do we calculate PB, pressure at B? Message done now. What is the technique that we can use? PA is 0, no? PA is equal to 0. That's all right. We have to calculate PB. How do we calculate PB? Yes, we have to consider the imaginary height. Okay. In other words, we have to extend this line. This is the free surface, no? So we can extend it with the same angle theta. So this is the imaginary water surface. You have to assume that the water is there. So theta AB, let's say this is C. මේ ටික අපිට හොයා ගන්න ඕන. PB. So one of the method that we can calculate PB is PB can be calculated like this. PB is equal to rho G H. Rho G H. This is H now. We can use rho G H. So H can be calculated because we know this AB. There's another way to calculate PB. It can be calculated by considering this direction. Now rho G is AX now. The X is AB. Right? You can see that tan theta is equal to AX over G. So by this diagram, tan theta is equal to H over AB. AX over G. So you can see that GH product is equal to AX into B. Okay. muted. All of you. So one of the method is we can use the pressure. The other method is we can think that we can think it as a curved surface. You know, if it is a curved surface, the vertical component of the force is equal to the weight of the liquid above the. You can equal to the weight of the liquid above it. මේ force එක මේ උඩටනේ එන්නේ. මේ pressure distribution එක මෙන්න මේ වගේ උඩටනේ force එක එන්නේ. ඒක එන්නේ අර 1:2 අනුපාතයෙන් තමයි මේ force එක එන්නේ. Okay, so you can use the weight of the liquid volume above the free surface, right? So that in that method the rho v is half into base is AB into height rho v again 2 rho vg. ඔක්කොටම එකම උත්තරේ විය ABH. මේකෙත් එන්නේ Sparks method rho gh 2 is cancelled rho gh into 6 minus A method AB. මේකෙත් එහෙමනේ rho gh. You can use any method to calculate it. වැඩේ තේරුණානේ කට්ටියට? So here is the translational motion. I only discuss examples involving horizontal acceleration, but there can be vertical acceleration and incline accelerations. So I will give you some solve problems in the homework, so you can go through them and complete the other questions in similar manner, right? Only thing is that we have to use this equation with certain analysis techniques. So I think better to have some break. After break, we are going to discuss the rotational situation. This is the translational. I only discuss horizontal translation, but you have to discuss vertical motion as well as inclined motion. Now we have completed translational. Then we will move into rotational motion. Hari? අපිට අද කලින් ඉවර කරන්න පුළුවන්, we can complete the lecture early today, but better to have a break and start. Okay, then we have to discuss rotational motion, right? So you can write down the topic rotational motion. Topic එක දාන්න rotational motion here. Rotational motion. You can write down the heading rotational motion. Okay, we are going to look at the second type of motion, rotational motion. Okay, so this is the liquid container at rest. Now, the container is subjected to a rotational motion along this axis. This is the axis of rotation, right? Subjected to constant angular acceleration. Constant angular acceleration. Constant omega constant. Constant angular acceleration. Angular velocity. That means there is no any angular acceleration. Angular velocity. Okay. If there is a if there's an acceleration, situation will be a little bit different. You can remember, right? So the effect is the free surface will be parabolic, right? There will be a parabolic free surface, and if this is the center, if this is the center of the, if this is the origin of the coordinate system, if it is x and y, then this equation of this parabola is given by y equals it's a parabola. Okay, it's a parabola. The equation is given by y equals omega squared over 2g times x squared. Okay, you have to use that in some cases. And the isobars will be, isobars means constant pressure lines will be set of lines like this. Shall we draw this and mention? හැමතිස්සෙම මේ මැදක්ෂ වටේම කරකැවෙන්න ඕන කියලා නෑ, මෙහිට එන්න පුළුවන්. ඒකට ඒ විදිහට යන්න පුළුවන්. Okay, those who complete this, you can start the next question available. Example 10 කියලා දාලා තියෙන එක කරන්න බලන්න. The effect is a parabolic curve, parabolic free surface. The equation of the parabola is given by omega squared 2g x squared. This is a constant angular velocity situation. The rotational motion is omega constant angular velocity. Everybody try to do example number 10. Example 10 එක කරන්න ගමු. I will share the question. An open cylindrical tank 1 meter in diameter. That one. Open cylindrical tank 1 meter diameter and 2 meter height. Contains water up to 1.5 meter depth. Open cylindrical tank. As a cylindrical container. Open, diameter is 1 meter. 2 meter high. Contains water up to 1.5 meter depth. If the cylinder rotates about its vertical axis, what is the maximum angular? Oh, it is going to rotate about the symmetrical axis. Vertical. Cylinder axis you can see that 2 meter height, 1.5 meter of water, no? So considerable amount of water is available. So this will be the new free surface. The equation is given by y equals omega squared over 2g times x squared. මේ තමයි කලින් වතුර තිබ්බ මට්ටම දැන් මේ තමයි අලුත් ෂේප් එක මේ টොප් එකටම ඇවිල්ලා තියෙන්නේ මෙතන තමයි ඔරිජින් එක this is the origin this is x and this is y this equation is given by omega squared 2g so thing is that you have to equate what in order to find omega you have to equate you have to equate the original liquid volume with the new liquid volume. Okay. So the original liquid volume is a cylinder, right? The new liquid volume is a cylinder minus this paraboloid. This is called paraboloid volume. Paraboloid. And most of the cases, as I explained earlier, it is easy to equate free space. So original free space is phi r squared h. Original free space is phi r squared h. Phi r phi. It's a cylinder, no? Look at phi. R is this is r. The radius r. R is half. Phi r squared h. H is this original space. It is also 0.5 and half. It is equal to, okay, it is equal to this volume. I think you can remember way that you have to calculate this volume. This is volume of revolution. Volume of revolution. Day level you have learned this. If you look at circular disc at distance y, this volume can be written as integral dv. No? So the dv is equal to this area is pi x squared dy. Volume v equals volume of revolution about y axis is given by pi x squared dy. So we can use that pi x squared dy within pi x squared dy. Pi into cube is equal to pi x squared. Now this is x squared. X squared is 2g omega squared times y dy. Y is the variable. The variable is varying from 0 to 0 to this y. Here you can find this y naught. 0 to y naught. 0 to y naught. Y naught means when x is half. When x is half, when x is at this level, මේ ටික තමයි මේ y naught කියලා දාන්නේ. උඩටම තියෙන උස මේ ටික. ටික තමයි y naught. Okay. x වලට half වෙනකොට y වල value එක y කැපිලා යනවා. එතනින් අපිට හොයාගන්න පුළුවන්. y is cancel 1/8 2g omega squared y squared over 2 y naught to 0. Two is cancelled. Omega y squared y naught squared y naught squared y naught වලට එන්න. Then you can find a value for omega squared. G එකක් cancel මටකුත් cancel අටයි G වගේ. අටයි දශම අටයි පහයි කියලා තමයි උත්තරේ තියෙන්නේ. අටයි දශම අටයි පහ. ඊට වඩා වැඩි වෙච්ච ගමන් if you exceed this omega what happen? Water is spilling out. If you further increase this top point, this O will reach to the bottom of this. It will further, if you further increase, water will further expand. There are several cases. Okay. The lowest point will reach to the bottom if you further increase, right? You can see the bottom with a particular radius at some instant. There are a lot of calculations and all, right? You have to spend time on these questions. You have to analyze, and theoretically, this is the only equation that you have to use. Y is equal to omega squared over 2g x squared. This is clear, right? You can remember this equation. V is equal to 5x squared dy. This 3D object is called paraboloid. 3D object is called paraboloid. Something like a sphere, it is called paraboloid. And this is a parabola. And the 3D space is a paraboloid. Actually, the fluid stat is the easiest part of fluid mechanics, right? The difficult part is the fluid dynamics. Therefore, do not take unnecessary stress, unnecessary difficulty on a stat. Stat is simple. Right? The dynamic is the difficult part. Because the fluid, in order to properly understand fluid dynamics, you should know the dynamics as well as calculus. In rotational problems, most of the time you have to calculate the volume of this solid object. Revolutionary of parabola. Okay, is it clear, all of you? All of you, is it clear? Right. I'm not going to discuss any more questions. I have discussed one question, but when you're doing homework, you have to always calculate this volume, right? Volume of a paraboloid. This 3D object is called paraboloid. Volume of the parabol. That means it's obtained by rotating a parabola, right? So the volume is given by a to b phi x squared dy. That method. Let's say the equation of the parabola is y equals kx squared in general situation. Your limits are r and h, right? Yeah, x coordinate is r and y coordinate is h. Therefore, x coordinate is k r squared. So you can find the value of k. So phi 0 to h now. 0 to h. X squared is given by y over k, no? Y over k dy. Let's see what happened. This k is a constant. So k is equal to h over r squared. H over r squared. So when we integrate y squared over 2, therefore finally it will be h squared over 2. You can end up with a nice formula. Phi r squared h over 2. Phi r squared h over 2. What is that? Phi r squared h is the volume of this cylinder. You can see a red color cylinder here. There's a cylinder. The cylinder having same height as the paraboloid, and the base is the same base, right? Therefore, the volume is half the corresponding cylinder. Half the corresponding cylinder. You can understand. You can remember when it is a cone, the volume of the cone is 1/3 of the cylinder. No? Therefore, the volume of the paraboloid is the half the volume of the cylinder. You can use that fact in order to solve a lot of problems. මේ විදිහට හැමතිස්සෙම integrate කරන්න නැතුව you can use half the volume of the cylinder කියන එක දාලා එතනින් ගන්න පුළුවන්. දැන් කලින් ගානේ වුණත් එහෙම ගන්න පුළුවන්, right? It's an additional fact. Sometimes you may have discussed that question in your A-level integration part also. Half the volume of the cylinder, 1/3 volume of the cylinder. Again. There's another example to be discussed. Shall we do it? I think it is example number 5. Type කරපු එක save කරගන්න බැරි වෙලා මම ප්‍රශ්නේ කියවන්න පොඩ්ඩක් ඒක තියාගන්න කොහොමද කියලා. It is not available in the tutor. You can write down the question. An upright U-tube manometer with its limbs 0.6 meter high and spaced 0.3 meter apart, contains a liquid to contains a liquid to a height of 0.4 meter in each lid. මොනවද කියන්නේ? බාහුව කියලා කියන්නේ each lid. YouTube එකක් ගැන කියන්නේ. If the U-tube is rotated at 10 radians per second about an axis at 0.1 meter from one lib and 0.2 meter from other lib, what would the levels of the liquid be in the libs? Voice typing එකක් දැන් මේකේ හරි. YouTube කියන්නේ මේ YouTube ගන්න video share කරන එක නෙවෙයි. YouTube is rotated 10 radians per second. About an axis means right here. An upright YouTube manometer with its limbs 0.6 meter high and spaced 0.3 meter apart contains a liquid to height of 0.4 meter in each. If the U-tube is rotated at the 10 rad about an axis at බලන්න ප්‍රශ්න කරන්න. Even though it's a YouTube, the continuous liquid, no, therefore we can use the same rule, right? It's a YouTube, upright YouTube. So we have to neglect the size of the diameter of the YouTube, right? Okay, points 0.4 meter. Limbs are spaced at 0.3 meter space and the height is 0.6. It's going to rotate, no, but the rotating distances are 0.1 and 0.2, no. Therefore, axis of rotation is not the symmetrical axis. එක පැත්තක ඉඳලා 0.1 අනිත් පැත්තේ ඉඳලා 0.2 වෙන විදිහට. එක දැන් ඒ ඇක්සිස් වෙන තැන එළිය තැනක් වෙන්නත් පුළුවන්. This axis. The omega is given as 10. The water level will change, right? Definitely, the higher the x, higher the y value, no? නිකන් rough එකක් ඇඳගමු. This is expected new situation. මේකෙන් පල්ලෙහාට යන එක තමයි අරගෙන උඩට යන්නේ. The liquid volume is constant. No? Let's say this is A. New y coordinate is A and B. B. Height to the origin is C. This is the origin. And the differences are D. ටික දාලා මොනවා හරි කරන්න. Omega is given as 10. So we can use the equation. Y equals omega squared. Omega squared is 100. 100. 1 over omega squared. Omega squared is 100. 100 divided by 2g. 2g. So it finally the constant is 50 over g. 50 over g times x squared. Right? If you apply it for the left hand side one, if you apply it for the left hand side column, y is a y is, yes, y is a is equal to 50 divided by g. We know value of g. X is x is 0.1, therefore 0.1 square. So we can apply similar equation for B, second limit. Then we can find value of A and B. AB හොයාගන්න පුළුවන්. AB හොයන්නකො. divided by G, 9.81 into 0.1 square. 0.051 approximately. Value of A. B එතකොට equation එක ලියන්නේ center එකේ ඉඳලානේ y equals kx squared වගේනේ. දශම දෙක දාලා ගන්නවා. 0.20204. There's another relationship between, we have to find D and C, CD. We can neglect the 0.3 length always. Initial liquid volume was 0.4 into 2. Initial volume. We can equate volumes now. Now that one is equal to that one is equal to two C plus A plus B. Okay, and the other thing is that B minus A is equal to 2D. We can find value of D and C now, then we can check whether this is practical situation or not. Height එක දීලා තියෙනවානේ 0.6 කියලා 0.6 වලට වඩා වැඩි value එකක් එන්නත් බෑ. Base එකේ තියෙන same volume නේ. Therefore 0.4 into 2 is equal to 2C plus 2C plus A plus B. 2C plus A plus B. 0.4 into 2 minus 0.51 minus 0.204. C divided by 2725, right? D එක ගන්න පුළුවන් difference එක විදියට. Okay, so now you can find the exact value. C දන්න හින්දා C ට A එකතු කරලා එහෙම ගන්න පුළුවන්. C plus B, you know, C plus B, it must be C plus B. These are the conditions. C plus B, C plus B. එක 0.6ට වැඩි අඩු වෙන්න ඕනේ. limb එක size එකට වැඩි අඩු වෙන්න ඕනේ. ඒ වගේ මේක. අනිත් පැත්තෙන් මොකද වෙන්න ඕන? අනිත් limb එකේ. එතන 0.4 is the original one. That one minus D. That one minus D is A, no? So that one minus D must be a positive value. These are the boundary conditions. In other words, C must be a positive value. Now C is a positive value, now therefore this is possible. If C is a negative value, that means origin is below the bottom of the U-tube, right? මොකද ඇතුලේ වතුර දෙකට බෙදිලා තියෙන්නේ වගේ වෙලාවට. බලන්න මගේ උත්තරවල මම ප්‍රශ්න තියෙනවා කියන්න simplification ප්‍රශ්න තියෙනවා. C plus B. Okay, I think this is clear for all. සමහරලාට C වලට නෙගටිව් වැලියු එකක් එන්න පුළුවන් ඔහොම හදාගෙන යනකොට. එතකොට තියෙන්නේ තව මේ කර්ව් එජ් එක පල්ලෙහාට ඇවිල්ලා තියෙන වෙන කර්ව් එකක්. හරි? අර පැත්තෙන් වතුර එළියට යන්න පුළුවන්. ඒ වගේ එහෙම වෙන්න පුළුවන්. Is this clear, all of you? So you know that the next week onward, we have to participate 3 sessions per week, right? So better to check the timetable, and you can see we are going to conduct electrical engineering as well as some maths. So there are 2 math sessions per week. I think we have 3D geometry mainly. In addition to that, we have polar coordinate and complex numbers. So better to follow the timetable and join the classes, right? I have already shared the timetable. Timetable is available in the demo class. Okay, so I'm going to leave, right? So go through the homework. You have to spend considerable amount of time with your homework.